How's it going, guys? Today we're gonna learn to find the magnitude or length of a vector. Remember that there's also direction, but today we're gonna bother with finding length or magnitude. Okay, and then we're also gonna apply that to another concept that involves direction. But first, let's figure out how to find the magnitude of a vector. Okay, and you'll see it's quite simple. So let's say that I give you these two vectors. Okay, we're gonna do a little bit of it together, and I'll get you to try the rest on your own. Okay, so let's try to find the magnitude of A. Okay, so remember what this thing looks like. Okay, remember that it looks like, basically, let's say that the vector starts here. Okay, 5i means that it's going to go 5 units to the right. Okay, and plus 3j means that it's going to go 3 units up. Okay, and that means that our resultant vector is this right here, right? So over 5 and up 3. Okay, now the question is, how do we find the magnitude of that? Well, hopefully from the picture that I drew, you guys can already tell me how to do that, right? We know that vertical and horizontal are perpendicular to each other. So we know that that length right there, which actually is the magnitude of A, is just using Pythagorean theorem, the square root of 5 squared plus 3 squared, right? So that's actually the square root of 34. Okay? Now the question is, can we simplify 34? Well, 34 is 17 times 2, and 17 is a prime, so no, we can't. Root 34 is the best that we can do. So the length of this vector is root 34 units. Okay? We can also say that that's approximately whatever the square root of 34 is. Okay, so I'll let you guys figure that out. Okay, so what I want you guys to do is I want you to try to find the magnitude of B. I want you to try to find the magnitude of A plus B. Remember, for A plus B, you're going to do A plus B first and then find the magnitude of that vector. All right, so make sure that you try that for tomorrow's class. Okay, now what I want to do is I want to apply that concept of magnitude to something called a unit vector. Okay, so let's say that I have the vector 3i plus 4j. So let's first draw 3i plus 4j. So that's 3i, 4j. So there it is right there. Okay, so first of all, what's the length of 3i plus 4j? Okay, well, remember, this length here is 3, this length here is 4. It's a right angle triangle, right? So we can use Pythagorean theorem, and we can say that the magnitude of vector v is equal to 3i. The square root of 3 squared plus 4 squared, right? Which ends up being the square root of 9 plus 16, which is 5 units. Okay? Now, so we know that the length of vector v, or the magnitude of v, is 5 units. Okay? Now we want to find a vector in the same direction as v, but whose length is only 1. Okay? Now, it sounds complicated, but remember the direction's fixed, so we really don't have much choice. All we're going to do is we're going to have to take this vector right here, and we're going to have to chop it into 5 pieces. Okay? So I'm just going to have to end it right there. Okay, so instead of it going all the way there, I'm going to have to end it there. Now the length is 5, so for it to have length 1, right, so that thing has length 1, okay, I need to have the old vector v, and what am I going to do with it? I'm going to divide it by 5, right? So this thing right here, right, so this is going to be the same as vector v, okay, except I'm going to divide it by 5. I can't divide a vector, but I can definitely multiply it by 1 over 5. Okay, so 1/5 of v is, it has the same direction as v, but has length 1. Okay, now let's check that it has length 1. And we know that the length of V is 5. So, yeah, the length of 1/5 V is definitely 1/5 times 5, which is 1. Right? So we've created a vector whose length is 1 in the direction of V. Okay? Now we'll talk more in class about why we want to do this, but let's try a couple more. Okay? So we want to find a unit vector. Now remember, a unit is 1 unit, right? So what we actually want to do is we want to find a vector of length 1. So this means length 1 in the direction of W. Okay? So the first thing we want to do is we want to figure out what the actual length of W is. Right? So the length of W is, remember Pythagorean theorem, 3 squared plus 2 squared. I'm going to go plus 2 squared because really if it goes up or down it doesn't matter. Right? So this is the square root of 9 plus 4 is 13. Okay? So root 13 is the magnitude of W. Okay? So that means that now instead of dividing by 5, I need to divide by root 13. Right? So that means that a unit vector in the direction of W is, so it's W, so 3i minus 2j, but I'm going to divide it all by root 13. Okay, so now the length of this is going to be root 13, and it'll cancel out with this to give me what I need. Alright, so that means I can multiply the 1 over 13 in, so it'll be 3 over root 13i minus 2 over root 13j. Okay? So let's just write down something. Okay? So a unit vector so that means length 1 in the direction of a vector V is, so remember it's always the same direction, so it has to be V, but I don't want it to have length 1, so I'm going to divide by the magnitude of V. Okay? So this is the unit vector, and the way that it's written is it's V with an arrow and a little hat on it. Okay, so V hat means unit vector. Alright? Okay. So that's all for today. I am going to give you one homework problem, okay, just to make sure that you can review. I want you to find a unit vector and the direction five, 6. Okay, so I want you to try that, bring it to class tomorrow, and that's that.